Hey everyone, in this video we are going to learn about solving quadratics using the quadratic formula. Now the quadratic formula is this big formula that you see here. And we are going to be looking at, once again, having standard form equations that are set equal to 0. And the solutions can be found using this big formula. Now, before we actually go through and plug everything into this big formula, we are first going to investigate what's called the discriminant. And it is what is underneath the radical. It doesn't include the square root, but what's underneath it. And what this is going to tell us is if we have 0, 1, or 2 real solutions. So if this discriminant is a positive number, we are going to have 2 real solutions. If this discriminant is a negative number, we are going to have 0 real solutions. And if this number is 0, we are going to have 1 real solution. Now, the reason is because if you think about what's under the square root, if I have the square root of, let's say, a positive number like 16, then if you look right in front of the formula, I have a plus minus. That would give me solutions like plus minus 4. And then with the rest of the formula. So that's 2 answers. If I had something like a negative underneath the discriminant or underneath the square root, so a negative discriminant, well, I don't have any values that works. There's no solution to this. So in this case, we can't find any solutions, which is why we don't have any real solutions. And then if the number was 0, well, the square root of 0 is just 0. So plus 0 and minus 0 are the same thing. And so that's why we get just 1 solution. So what we are going to do first is we are just going to determine the discriminant and find the number of real solutions. So in my quadratic formula, the only part I want to pay attention to is the discriminant, which is b squared minus 4 times a times c. So before I do anything, I want to make sure, is my equation in standard form and everything set equal to 0? Yes, it is. And then from there, I can determine my a, b, and c. Well, a is equal to 1. That's the number in front of x squared. B is equal to the b term, which is negative 4. That's the one in front of x. And then c is equal to my term by itself, which is 3. So now from here, I am going to go through and I am going to plug into my formula those different values. So instead of b squared, I am going to plug in negative 4 squared. And then this minus 4 is always a part of the formula. That's never going to change. And then I have times a times c. So times a would give me times 1. And times c is going to give me times 3. So all I did is I replaced again my b, my a, and my c. And now from here, you can do this math by hand if you want. Be very careful with your order of operations. If I were to do that, first we would have to get our 4 squared, negative 4 squared is a positive 16, so be careful with that. And then negative 4 times 1 times 3 is a negative 12 or a minus 12. And 16 minus 12 is 4. So because my discriminant is a positive number, that means I'm going to have 2 real solutions. And we'll see that again once we look at some examples of the quadratic formula. Now, I did want to show you what that's going to look like in your calculator as well. So the nice thing is you can do it by hand like I just did, but there's a lot of room for error if you just miss your negatives or parentheses. So I can plug in everything that I see here into my calculator just like that. So let's do that. So we had b squared minus 4ac. We said we had a negative 4 squared. Notice I am putting that negative 4 in parentheses because you need to make sure you are squaring the negative as well. So always when you're plugging in numbers, put in parentheses. And then we have minus 4. And then instead of a, I am plugging in my 1, which in parentheses again, and then times c, which in parentheses we had 3. So just like how I had written it before, and then you can hit enter and you get 4. So you can do it by hand or you can let your calculator do the work for you. All right, go ahead and I have 2 more examples for you. See if you can find the discriminant. So first, make sure that you are setting your equations equal to 0, and then you can go ahead and find your discriminant, and based off if that number is positive, negative, or 0, that will tell you how many real solutions you have. When you're ready to check your answers, go ahead and unpause the video. All right, in that first example, we did have to move the 4 over to the other side, so we subtracted 4, making sure that your answer or your final equation is in standard form. Identify your A, B, and C, and we get a discriminant of 0. So because my discriminant was 0, that means there is 1 real solution. Then, if I look at my second example, I had to move the 4x over to the other side. And notice when I subtract it over, I do put it in the middle because it's my x term. My x term should be in the middle. And so that gives me the correct A, B, and C. And when I plug that in, I get a negative 4. So because this discriminant is negative, I don't really care what the number is, but because it's negative, there are 0 real solutions or no real solutions. So now let's actually see an example of the quadratic formula. Now, this formula looks pretty complicated, so my first recommendation is still to find the discriminant. So just like before, I am going to move that 4x over, and I get 3x squared minus 4x plus 1 is equal to 0. So I am going to first find my discriminant. I'm going to identify my A, B, and C. A lot of B equals negative 4s here. So for b squared minus 4ac, I would get, in parentheses, negative 4 squared minus 4 times a, which is 3, times 1, which is, or c, which is 1. And now I can solve that. I get 4. Oops. So now we can go through and we can look at plugging into this whole formula. So I have x equals the opposite of b. So I am going to replace b with what I'm saying b is, which is negative 4. And then plus or minus the square root. Well, now this is why I like to find the discriminant first, because we have to find that b squared minus 4ac underneath. I already did that to give me plus or minus 4. And now that is all over 2 times a, which here in this example is 3. So notice everything in black will always be a part of your formula, and then everything in blue, red, and purple, that's what's going to change each time. Now this can seem pretty daunting, so my recommendation as you're doing this would be to simplify each piece at a time. So right now, first, I'm going to look at that first term, which is a minus 4. When we say negative b or the opposite of b, really you can see that that minus in front is going to switch the sign. So that is going to become a positive 4. And then I have plus or minus the square root of 4. The next thing I can simplify is this square root if it simplifies. Now in this case, the square root of 4 is going to be 2. And so I can write it as 2 all over. I can now simplify that bottom piece. So now I can simplify this piece right here. That is going to give me 6. Now, when we have this plus minus, we do have to split it into 2 different equations, one with a plus and one with a minus. So for my first equation, we would have 4 plus 2 divided by 6. And for my last equation, I have 4 minus 2 divided by 6. So everything stays the same except for I'm just changing that plus minus here in front of the 2. From there, be careful with your order of operations. Simplify your top first. So 4 plus 2 is 6. Divided by 6 is 1. And on the bottom, 4 minus 2 is 2. Divided by 6 is either going to be 0.33 or 1/3. I don't really care. In the next problem, we'll look at some decimals, so we can round to 2 decimal places and give 0.33. So my answers are x equals 1 and 0.33, or if you did want to write it as a fraction, 1 1/3. Here's another example. Why don't you go ahead and pause your video and practice finding the discriminant and practice plugging things in. So first make sure that you are moving all your terms to one side of the equal sign, but then you can go ahead and find your discriminant and plug in your terms. All right, so with my discriminant, I got a 281, and you'll notice I like keeping my a term positive. If you moved the 5x squared, you would notice that your signs would be different for your a, b, and c, but it should not impact your discriminant. And then some of your signs might be different in your final answer, but if you simplify it, just like I do, your answer should still be the same. So here I plugged in everything. I have my negative 9, because b is -9, plus or minus square root of 281 being my discriminant, all over 2 times a, which is 2 times 5. So now if I simplify this, I get x equals, well, that becomes a +9, plus or minus. In this case, you can check on your calculator, but the square root of 81 does not simplify. So I'm actually going to leave it as the square root of 281 for right now, all over 2 times 5, which is 10. Now, when we do this, I can still split it up into my 2 equations, 9 plus the square root of 281 divided by 10, and 9 minus the square root of 281 divided by 10. We are going to get decimals, and I'm going to show you how you can plug it into your calculator to make sure you get the correct answer. Basically, the fraction, you have to do the numerator first before you divide by 10, so I'll show you 2 different ways you can do that. Because we want our numerator to simplify first, the first thing we could do is we could put parentheses around the 9 plus square root of 281, and then make sure you do have to go to the right and get out of that parentheses, but then divide by 10. That tells your calculator that you want to do the addition first on the numerator. You have to put parentheses if you do it that way. The other way you could do it is you could do 9 plus the square root of 281, hit enter and get that decimal, and then hit divide by 10, and you'll get the same answer. What you cannot do is type in all of this at once, because then your calculator is doing order of operations and it's only dividing the square root of 281 by 10. So make sure you always do the either parentheses around the numerator or do it in the 2 separate steps. So notice I wrote down a lot of the decimals just so that I can check my rounding, but then the final answer did want it to 2 decimal places, and so my answers are 2.58 and -0.78. The last thing to cover quick is real-world examples. Now, we already talked about real-world examples, and that's just looking at that x-intercept. So when will something hit the ground? So you're looking at your x-intercepts, so it's really just using the quadratic formula and then making sure you're doing positive answers only. So here we have a frog jumping off the rock. You can see the equation there. So why don't you go ahead and do your quadratic formula, pause the video and see what answer you get, and then unpause to check your work. Here's your final answer, so you can go ahead and pause it if you need to kind of go through the work. But as a reminder, when we're doing examples that are word problems, we only want the positive answer because our time can't be negative. And so for this answer, it would be 0.693 seconds.